Modeling exercise M2 with the focus. Window layout, cylinder and threaded hole. In NX, you can open several parts and display them in separate windows. You will also get to know the many options for threaded holes. You will find a drawing for the part as a download in PDF format for printing. Or you can open it on a second screen. Window layout. Create the new exercise part by clicking on File, New. Select the Start Part model, and enter the name and folder. Click OK, or press the Enter key on your keyboard. Together with the part from the last exercise, another tab is now displayed at the top of the graphic window. By clicking on any tab, the part is selected and can be edited. A tab can also be dragged to the center of the screen by holding down the left mouse button in order to split the screen vertically or horizontally. The tab can also be dragged to a second screen. If the tab is dragged back to the center, the original display is restored. Create another part for testing and accept the name with OK. With 3 parts, you can divide the screen even further. This leaves less space for each part, but with this display, several parts can be compared or presented. If the screen is split several times, the individual windows can also be reset via View, Window, Reset Layout. You can now close the test part by clicking on the cross. This message appears, and you can choose whether you want to save the part before closing, or close without saving, or cancel the operation. Create cylinder. To create the basic body of this simple part, the command cylinder is sufficient. You will find the command in the group Basic, under More. Usually, the cylinder is created with the option axis, diameter and height. However, an arc can also be selected. A short test. Cancel the command and switch to the first part of the exercise. Here you can select any arc with the option arc and height. The selected arc then controls the diameter and the axis. Only the value for the height still needs to be entered. But back to the exercise. With the axis, diameter and height method, the vector is specified first. For example, by selecting the absolute axis, 2 points in space, and so on. In fact, however, the alignment and position of an individual part later in an assembly hardly plays a role. The parts are then positioned individually in the assembly, because otherwise the part would have to be designed in this position beforehand for each positioning in the assembly. Now select the z-axis as the vector, and the 0 point as the point. Enter the diameter and the height and click OK. Threaded holes, overview. The next step is to create the threaded holes at the ends. But first an overview of the options. The command hole also contains the threaded hole. The normal, metric thread type can be found at the top of the list and is called metric coarse. However, fine threads, helicoil threads and various inch threads can also be selected here. The size selection changes according to the selected thread. But back to the standard thread. The tap drill diameter, or core hole diameter, can be changed via radial engage. Usually, the value is set to 0.75 and thus produces the typical core hole diameters. The value 0.5 produces enlarged core hole diameters, for use in rough, dusty environments, such as construction machinery. And individual core hole diameters can be entered after the custom setting. Under thread depth type, there are several options for defining the thread depth as a factor of the nominal diameter. With the custom option, individual values can be entered. And with the full option, a thread is created over the full length of the hole. The depth of the core hole is either selected with the depth limit, the thumbnails of which are self-explanatory. Or the depth is automatically adapted to the thread depth, with the option Relate hole depth to thread depth. Example: if 4 is selected as the pitch multiplier, the core hole would always be 4 times deeper than the thread depth. For M8, this would be 5 mm. Creating a through-hole thread. This thread is created with the setting full, and the depth limit through body. With a long through-hole thread, production becomes difficult. Activate the wireframe view here, to see the thread better. To create a short thread, in both ends of a through hole, activate the hole by double-clicking on it. Then select a typical thread depth and activate the option Thread both ends of through hole. This will automatically create a thread at both ends of the through hole. NX shows the thread only symbolically. The dashed circles show the beginning and end of the thread. Activate the wireframe view here, to see the thread better. If the option is not available, activate it in the border bar options under View Group, Display Style drop-down. Relief and chamfer. With the option Apply Relief, the threaded hole can be bored free in the upper area. To be able to change the preset values here, radial engage must be set to custom. This creates a larger hole before the threaded hole starts. With the custom setting, you can enter the desired diameter, depth, and angle of the hole. With the chamfer option, a chamfer can be created with start chamfer at the beginning of the hole, and with end chamfer at the end of the hole for through holes. Here too, the following applies: to be able to change the preset values, radial engage must be set to custom. Otherwise, the diameter corresponds to the nominal diameter of the thread. Create threaded hole for the exercise. Select the settings shown in the hole command to create the threaded hole for the exercise. Select single point and edge. Check the snap options. Only arc center should be active. Click on the upper and lower edge of the cylinder. Check the counter behind specify point. This should display 2. If this is correct, click OK. This means that several threaded holes can be created at the same time, even if the individual holes point to different directions. To change the number and size of the hole, just double-click the hole in the graphics window. If you do not set a selection filter, and hold down the Shift key, you can deselect a selected item by clicking the left mouse button. In a drawing, the set values, such as thread depth, nominal diameter, core hole depth, and so on, can later be read out as dimensions. And for 3D printing, the thread can also be created in detail. This will be discussed in a later exercise. Chamfer. Now only the chamfer is missing. Select the settings shown in the chamfer command and select upper and lower edge of the cylinder. Use reverse direction to correct the chamfer direction if necessary. In the next video, we start with the first sketch and learn more about the hole menu. See you in a bit. At LearnNX.com you will find this and other exercises. As a member, you can also access the site without advertising, along with practice materials and, if you wish, a certificate. I'm always open to ideas and suggestions. Write in the comments or directly to info@learnnx.com.